Dear colleagues, my warm greetings of the day and welcome all of you to Asian Polymer Association Sustainability Forum. In our mini lecture series on sustainability of materials, today I have an honor to welcome Professor Seeram Ramakrishna, who is currently serving as Professor and Director of Center for Nanotechnology and Sustainability at the National University of Singapore. Professor Ramakrishna received his PhD from the University of Cambridge, UK, and is a highly cited researcher in the world in material science, with recognitions as one of the world's most influential scientific minds. He is a member of UNESCO Expert Group on Universities and the 2030 Sustainability Agenda. He is very active in different forums of material science and sustainability and have received many recognitions and awards. Today, Professor Ramakrishna will share his views and his work on circularity and sustainability of the plastic. Let's hear expert talk of the subject from Professor Ramakrishna. Over to Professor Ramakrishna.
Thank you, Professor Gupta, for your kind introduction. I'd like to say a warm welcome to all the attendees of the webinar. This webinar has 3 parts. First one is we conduct a sample survey of 10 questions, and it will take about 3 minutes, followed by my presentation for 20 minutes, followed by 10 minutes of Q&A from the audience. Niranjan, can we start the poll?
Yeah, we're starting the poll. Each questions will be given for 20 seconds to answer.
Yeah. The audience, the idea is to know you more closely. Please take the poll, give your answers. You have 20 seconds for each poll. So now you are going to take the second poll question. Is sustainability of plastics important for you? Please choose no, maybe, yes, as long as there is no cost increase, and yes. Please make your choice. Thank you. We move on to the next question. Is sustainability of plastics important for your organization? Again, these are 4 multiple choices. Please make your choice. Thank you. We move on to the next question. Question is 100% sustainability of plastics to be realized via mandatory recycling targets, banning plastics from use, replacing them with green alternatives, new technological breakthroughs. Please make your choice. Thank you. We move on to the next question, which is standards for sustainability of plastics. Not available. New standards are necessary, available but vague, adequate. Thank you. We go to the next question. Are plastics circular? No, yes, not sure. I do not understand the question. Make your choice, please. Thank you. So we are into our last three questions. Are plastics sustainable? Make your choice among the four potential answers. No, yes, not sure. I do not understand the question. Thank you. This is the next question. Transitioning from point of consumption thinking to life cycle thinking is feasible by the customers. Unsure, never. Yes, with clear labeling, yes. Please pick one among the four as your choice. Thank you. This is the last question. Please answer this. I believe in the effectiveness of the following sustainability measures: extended producer responsibility, carbon tax, carbon footprint labeling, ESG reporting, all of those. This is the 10th question out of this poll survey. Is zero waste society ever feasible? Unsure, never, yes. Yes, with strong efforts by all the stakeholders. Thank you very much. So Niranjan, if you can I share my slides, Niranjan? Screen. Okay, thank you. Well, very good afternoon to the audience. Thank you for joining this webinar. I'd like to pick two of your poll survey responses to the question, are plastics circular? About 11% of you said, I do not understand the question. And about 1/4 of you said no. And similarly, for the poll question, are plastics sustainable? Majority of them, more than 50%, said yes, and others said not so sure. But luckily, nobody answered that I do not understand the question. And with that as a backdrop, next 20 minutes, I would like to present to you circularity and sustainability of plastics. Niranjan, I need to share my slides.
It's a visible, sir. It's a visible.
Is visible? Okay. But I cannot see them. Never mind. Okay. Got it. Okay. So I like to emphasize why, what, and how we should go about circularity and sustainability of plastics. To answer the question why this is important, let me show the numbers. The last 70 years, close to 6.5 billion tons of plastic waste was generated. It is almost equivalent to 1 ton of plastic for each person living on the planet Earth. Only 9% of the plastics are recycled properly. Rest of them are thrown away in the open natural environment or in landfills. In terms of yearly perspective, right now around the world, we are producing 400 million tons of plastics. Going forward, by 2050, that number would double to 800 million tons of plastic per year. And if you only recycle properly, less than 10%, you can imagine bulk of the plastics are left to impact our environment, which is the natural ecosystems of the planet Earth. According to half-life measure of plastics, here I'm showing you the most popular plastics. What is their half-life in the land and in the ocean? You can see their half-life is more than 100 years. This is one of the cause for concern among people around the world. Even other interesting aspect, they also found out microplastics, leachates coming out of plastics that are improperly disposed in the natural ecosystem seems to be causing male infertility. So that has a major impact on the human health and well-being. Considering polluting effects as well as human health effects, while plastics are extremely important for modern life, different countries around the world putting together national regulations by emulating best practices elsewhere. In this case, I'm showing India, Sri Lanka, Indonesia, Singapore, Japan, South Korea, China, and Australia. As you can see, all these countries have already introduced certain type of legislation aimed at controlling the waste disposal with respect to the plastics. Singapore already introduced extended producer responsibility, which means the large producers of plastics, be it in directly product manufacturing or plastics used in the packaging, they are responsible in collection of the plastics, reporting how much of these plastics are recycled appropriately. Very sure other countries like Japan, South Korea, India, other countries are doing similar policy measures to improve a proper handling of the end-of-life waste management of plastics. Now the next question is, so far I addressed why plastics management is necessary. Next two questions are how and what. If you look at the most popular plastic recycling methods, initially most countries were looking at thermal recycling. That means they harness energy from the plastic waste. There is also capacity buildup for mechanical recycling, also chemical recycling. In other words, instead of throwing away in the environment or landfilling, countries are beginning to properly collect the plastic waste, and they're either employing the method of thermal recycling, more recently mechanical recycling, and a chemical recycling. Below, this is the Plastic Recycling Association of Singapore. We formed this about a month ago in line with the Extended Producer Responsibility Guideline. Singapore is pushing ahead in introducing stronger measures in plastic end-of-life waste management. This association is also in the works to establish a center of excellence in Singapore with the idea of emulating best practices in European Union, customizing to the Singapore needs, as well as adopting these to the situations in ASEAN countries. One of the area which we would be looking at is the mechanical recycling, more particularly large volume plastic waste. In view of the time, I'm not going into the details, but on the right side, you do see different boxes with an emphasis what are the topics we will be focusing in plastic recycling. Similarly, we are also promoting startup companies, technology companies in Singapore. In this case, young people like Sajid, Sophia, they're very passionate, motivated, and establish a company called Anti-Plastics. And if we compare this anti-plastic with other technologies out there, we need to employ the concept of sustainable thinking. In the past, plastic waste management is more seen as how do we take care of the waste that is disposed. But moving forward, are we disposing the waste, especially plastic waste, in sustainable way? Sustainability of waste plastics involves understanding the impact of plastic waste on the natural ecosystem of planet Earth. They could be in terms of greenhouse gas emissions, excessive energy consumption, types of energy it is utilized, as well as post-processing products and byproducts, the value add they create. In this case, anti-plastics uses a molecular method or a chemical recycling method, and how it compares with the other methods like incineration, landfilling, pyrolysis, and mechanical. And of course, it is in the interest of technology companies to self-benchmark how their particular technology compares with other technologies out there in other countries. Other aspect is each company has their own ecosystem, and they actually optimize how they fit their solution to the waste streams that are coming out in their own country or in their own community. Here is an example how we can compare a particular waste recycling method with other competing solutions as well as companies. Anti-plastics is looking at PET recycling, but PET recycling itself involves different scenarios. A scenario one, a PET that is need to be recycled is segregated, it's a clean and a straightforward and suitable for direct recycling. Other one, PET waste is associated with the multi-layers and requires a more customized adaptation of the technology. You could also imagine another situation where plastic waste is mixed, and how do you go about in dealing with the mixed plastic waste? So here is a circular economy thinking by a company called Anti-Plastic. I'm very sure different companies that are operating in this area would have a somewhat similar visions with the different approaches. So far, I described how do we go about sustainability of plastics through the lens of recycling methods. There is also another strand of development, that is substituting fossil fuel generated plastics with a nature renewable sources based bioplastics. And there are many examples where companies are trying to replace fossil fuel derived plastics with the renewable natural biosources derived plastics. When such plastics are more conducive to the end of life sustainable disposal, functional properties requires further tweaking, and they resort to biocomposite methodology. It is also possible to combine renewable sources derived materials mixing with the fossil fuel derived plastic so that you enhance degradation abilities of fossil fuel derived plastics in the natural ecosystem. So these are schematics, but all these works are published in literature and you can check them. Some other companies or some other organizations are exploring what they call carbon offsets or carbon credits and carbon trade. What it means is they invest in other projects that are deemed to be environmentally friendly. For example, forestation, reforestation, or carbon sinks in the form of mangroves. They could be estimated in terms of how much carbon they're absorbing. And these carbon offset projects can be invested by the companies or the organizations that are generating waste. So those of you attending this webinar, I noticed 1/3 of you are either students or professionals. You are looking for opportunities for your future. You may not be involved directly in polymer processing or plastic recycling, but you could also involve in thinking about carbon offset projects. Make sure those projects are properly maintained and third-party evaluation is done so that that particular carbon offsets can be sold to the polluting companies who might be interested in buying the carbon credits. So this is a fast-growing area worldwide. So if you are interested in sustainability of plastics, this is a adjoining growth area that you might be interested to consider. In addition, listed companies in Singapore as well as major other countries, they are now required to report what they call ESG reporting, environmental social governance. And on the right side, I'm showing over 2,000 companies surveyed by McKinsey, about 63% reported they actually made a better gains because they have a ESG thinking in their governance and various processes of the company. So if you are an aspiring individual or a company trying to plug into the globally emerging sustainability industry, which is estimated to be several $billion, you might learn about ESG reporting, and you could also focus on the interplay between plastic manufacturing, recycling, and ESG reporting, so that you can leverage how your own understanding in plastics can be linked to the ESG reporting of the companies and find your own future opportunities for yourself. And while ESG reporting has been embraced by a number of companies around the world, there is also criticism. So there is a widely held perception greenwashing by ESG reporting is being done by the companies around the world. But moving forward, I believe there are good practices proposed by European Commission, what they call Sustainable Finance Disclosure Regulation. So these guidelines put forward by European Commission are highly curated and seen very useful in making the ESG reporting more transparent, much more reliable. So if you're a practicing professional, I really encourage you to understand SFDR regulations and also see how and which companies are reporting on ESG. These are the consulting companies. You can learn and find your own way of understanding, embracing ESG, perhaps for your own organization or you as an individual to become a professional in sustainability. So far, worldwide, we look at all the companies, how well they are doing in terms of the United Nations Sustainable Development Goals, as well as sustainability targets. Sadly, most companies are still behind their own set targets. In other words, in the future, there would be a lot more stress, momentum for these organizations to prove and live up to what they are promising to the world. There is also thinking that is being proposed, right to repair legislation. Right now, many products, they are designed such a way they're not suitable for repair, are not easy to repair. Perhaps in the future, people are pushing for right to repair legislation so that recycling of plastics, not only plastics, but other forms of waste like electronic waste can be enhanced. In other words, to improve the sustainability of plastics, we need to enhance the recycling rates of the plastics. And that comes through a variety of measures like ESG measures, carbon footprinting, life cycle analysis, and also legislations like extended producer responsibility and right to repair future legislations. My journey into this particular sustainability of plastic started about 10 years ago when I met passionate Italian, Angela Daniela. We work in similar areas on polymers and plastics, but when I met her, I understood she has been focusing on environmental impacts of the plastics. So environmental impact of plastics is a key strand of sustainability of plastics. Since then, I got involved in this domain much more deeply. As you can see from this slide, I'm very actively involved in ISO committees that involves in circular economy, circularity of materials. And I'd like to illustrate the concept of circularity, which is a new phenomenon, a new concept that is being worked on by the ISO. It is a standard called ISO 59020. And you see here is the committee meeting involving more than 215 people, experts from around the world. We have several meetings in a year. It's an ongoing process. This particular image tells you to make this standard widely acceptable, we need to cross several peaks. We're at the beginning of one of the peak. What it says is ISO 59020 is a framework applicable to multiple levels of an economic system, ranging from national to regional, individual, and groups of organizations and products. And this particular ISO standard is built on leveraging existing circular economy ISO standards, ISO 59004, Circular Economy Framework and Principles for Implementation, ISO 59010, Circular Economy Guidelines for Business Models and Value Chains. So, as I said, previously I explained sustainability, which is much more built on the environmental impact of the manufacturing processes, products, and end-of-life waste management. The two words, keywords that are emerging, one is circularity. Circularity is a state of a specified system, organization, product, or a process where resource flows and values are maintained while benefiting sustainable development. The key word is values are maintained. That is circularity. Sustainability is focused much more broadly in terms of environmental impact, health effects, and overall sustainability of future generations, where circularity is much more focused on retaining value of the material or a product or a process. And circularity performance is a degree to which a specified system, organization, product, or a process represents a state where resource flows and values are maintained while benefiting sustainable development within a defined time frame. So performance in terms of circularity is about maintaining the value in the given time frame. So now I'm going to take you through more details how this particular circularity process needs to be understood. Previously, we already have standards related to life cycle assessment. There's an ISO standard. There's a life cycle sustainability assessment, life cycle costing, material flow analysis, and other standards. Similarly, there are a number of ISO standards available for reporting and communication. So they are built based on certain principles. So this particular new standard that is being worked on, circularity of materials, built on applicability, transparency, traceability, and data reliability. And how we actually go about in measuring the circularity performance of a particular system. Here you have a resource flow. You track the resource flow, and each process step, you understand resources in, resources out, as well as the products, services, as well as emissions. So a variety of those things. And a schematic below, which is more detailed, where we are talking about the natural resources and at a different process level, what is the value, how much of that value is retained within the system. And the same thing can be understood a little bit more deeply In this case, you have requirements you set the boundaries you want to analyze, you acquire the data, and then you start assessing the circularity measurement. You apply your assessment methodology in the particular context. What is the circularity strategy? What is the economic system? What are the levels or boundary conditions you are establishing? What's the value to the network? What are the complementary methods you are leveraging? So in terms of the business model of that product or a company, you can look at from the patterns, from the elements, as well as the key enablers. And these are the most details. How do we go about circularity measurement? And how do we link these circularity measurements to the total sustainability taxonomy? So you have this ISO 59020 circularity measurement and assessment taxonomy. So taxonomy would have circularity indicators, data acquisition, and circularity assessment. And they could be categorized, and each category would have indicators. And once you collect the data, you can link it to the regenerating resource value, retaining resource value, adding resource value. So I give an illustration, for example, resource inflow. You could look at indicators that represent circularity of resources flow. For example, fraction of input material that is derived from circular sources or recycled content or renewable sources. Similarly, another indicator, resources outflow. You could also look at emissions. You could look at other waste streams like waste, and you can look at the fraction of solid waste as an outflow that is recycled by your own organization or external organization with proper documentation. Similarly, energy, water, and you could have other indicators like economic indicators. Depending on the product or a service, you are trying to do the circularity assessment. So linking the circularity indicators to the circular economy benefits, one could go about a complex Excel calculations, or you could create a computer software which automatically computes this information. And these are the most detailed articulation, how you can articulate circular economy or sustainability benefits by linking to the circularity performance assessments. And key aspect in circularity assessment is the data acquisition. What I notice, most companies around the world do not yet have a good practices in collecting the data, curating the data, making the data available much more dynamically, and make the data verifiable. So organizations or the researchers, students interested in circularity linking to the sustainability of plastics or products and processes need to understand data acquisition process. These are the challenges. When I work with the companies in Singapore, we recognize there are a number of challenges. So gathering the data is a problem. Also, there are issues related to collection, sorting, labeling. This is also some other problems. In some companies, they are trying to leverage Industry 4.0 technologies like IoT, sensors, artificial intelligence, blockchain, big data analysis, so that they can on-site collect the data as the processes are happening. And this data is fed into the internet-based platforms, and they are analyzed. information is sent back to the operators so that they can improve the manufacturing processes as well as services. But this poses another set of issues. Many of the people that are working in the organization, students, professors, they do not yet have sufficient digital skills, deeper understanding of the sustainability indicators, as well as how to go about reporting the information. So this requires a lot more learning on the part of every individual, every stakeholder in the ecosystem. So there's a lot more pointers. I have it in this slide, but I would not go through them because of the time. But essentially, for a country, organization, or individual to systematically transition towards sustainability, circular economy, circularity requires a deeper understanding and a systematic way of going about. When that is done, the whole process system become more transparent, more valuable. Ultimately, they can create new jobs, also improve the natural ecosystems for current generation as well as the future generations. So with that, I like to summarize what I said so far. Also, I want to stay within the time allocated for this particular webinar. This slide is given to me by my collaborator, Professor Christian Paulik from Austria. He is running a Chase center that is focused on recycling of plastics. And you can see here is a schematic, looks at total end-to-end, several aspects involved in generating circular economy, sustainability solutions for plastics. Here is a slide I have taken from Sharp, is a company, a Japanese company, that talks about it is not only recovering the waste plastic, converting them right now to the commodity plastic is where most companies are focused. But moving forward, we need to upcycle plastic materials to retain, even further enhance the value so that circularity of plastics become much more valuable. So in this case, companies like Sharp are thinking about functional plastics from the waste plastics. So this requires a much deeper understanding of the process, the science and technology behind it. When these things are achieved and realized, we would realize the dream of circular plastics. So I like to put a cartoon of my vision for circular plastics. Moving forward, the sustainability and circularity of materials, in this case, plastics, based on which products and services are made, will become more important in the decarbonization efforts of the companies as well as the governments around the world. Right now, most countries and large companies announce they would want to be carbon neutral by 2050. In other words, materials, products, and services need to embrace sustainability and circularity principles. For scientists, researchers, the good news is this calls for new science and technology of atoms, molecules, circular product designs, and circular economic models. In other words, these could be the students learning in the science and engineering schools, they could be in a business schools, or they could be design schools. They all have a role to play in the future development of more circular, sustainable products and services. I'm now coming to my last slide. As I said, most governments and large companies around the world committed themselves towards carbon neutrality by 2050 or 2100. Recently at the Earth Day Summit, they pledged such a lofty goals. Here in this particular schematic, I looked at every human endeavor. What is the high level best endpoints and technologies we could consider? What I call at 2020, the world is producing about 34 billion tons of CO2. And moving forward to a zero carbon world by 2100, you could imagine a variety of areas where we could make a substantial progress in science, technology, business, and economic models. If you are really interested in this particular broader topic, I welcome you to look at this particular post. I posted it last week at Springer Nature Sustainability Community. With this, I'd like to end my webinar. Thank you again for your participation. Professor Gupta?
Yeah. Thank you very much, Professor Ramakrishna, for your exciting talk and giving the linkages between circularity and sustainability, which are very important in addressing the current challenges faced by the society. Let me take some questions first. There is one question from Mr. Jeevan from Nigeria. Is chemical recycling is a part of circular solution?
Thank you for that question from far away, but I'm glad that you joined the webinar. Yes, circular chemical recycling is part of the sustainable plastic development, but there are criticisms in terms of energy utilization, as well as some of the chemicals and resources that are being consumed in the process of chemical recycling. But I think that is a very broadly understood way. But if we can find a closed loop system in terms of all the energy, chemicals, the other things that go in the chemical recycling process, you could make the process a lot more efficient, much more environmentally friendly. As I showed in one of my slides, you have to systematically compare this process with other processes, and also which particular ecosystem you are trying to develop the solution, and accordingly you would have a better answer. Even though it might appear in a particular ecosystem or a particular context, when you change the boundary conditions, you might find your solution could be a good solution.
Thanks, Professor Ramakrishna. The second question is a very interesting question. Is material waste is a result of unsustainable service, or can sustainable service avoid plastic waste? Can you comment on that?
Yes, I'm trying to understand the question deeply. Can you repeat it again? Because I want to understand the question appropriately.
Okay. Is material waste a result of unsustainable services? Or in other words, can sustainable service avoid plastic waste?
Okay, thank you. Yes, I think the material waste does not happen by itself. It is linked to the services and the way the business models are organized. For example, in some countries, they advocated shared economy or shared services. So when you have a shared services, the amount of material wastage would be lower. So in other words, by understanding and relating how the services are being delivered and what is the linkage to the material waste. If that can be understood appropriately, I do believe we can mitigate or at least reduce the material waste by also looking at innovative solutions in a services delivery. Thank you. That's a very interesting question.
I think there is a one question on quality assurance and control. What approaches are being planned for quality assurance and quality control for sustainability aspects?
Right. Thank you. So right now, there are many standards are already available for the materials quality reporting. So the new standards are coming in terms of how organizations should report this information. Second one, the testing companies like TU Sud as well as other companies, they're also developing methodologies for specifically characterizing, testing, reporting recycled materials. And if I recollect, they are doing these particular advancements based on the existing standards, keeping an eye on the new standards that are being proposed. As I said, ISO TC 323, which is on circular economy, as well as circularity. These are the new concepts coming up, whereas the existing ones on sustainability, all other life cycle assessment, life cycle engineering, and other carbon footprinting, there are already such methodologies and standards are already there. So if you are a materials engineer or a materials scientist, you are looking at a much more core testing standards. They are same standards. It is only you are changing the material that you would like to test, but the rate of testing, number of samples testing, how do you analyze the results statistically, and how should you report the results, and data transparency, very much similar. So if you are thinking or worrying about, do you need to adapt too many new standards? No. I think in terms of material testing, whether it is a virgin material or recycled material, at the mechanical, physical, chemical property evaluation, they are the existing standards are suitable. But when you are reporting that information, especially when you want to leverage industrial symbiosis, that means your waste material is actually a input value material for another organization. At that time, you need to provide more information so that other company can develop their products based on the information you produced or you generated. So the key point to remember is you still utilize the existing standards, but you complement the existing standards with emerging new methodologies so that you are now reporting the information much more acceptable way for the sustainability community.
Thanks. Although there are many questions, but I will just pick up two more questions because of the time constraint. There is a questions on this medical plastic waste. In recent time, due to pandemic, use of single-use plastics in medical field has skyrocketed, resulting in generation of lot of medical plastic waste. So do we need to change our plan or delay our target related to achieving our circularity?
Thank you for that question. In fact, recently we just wrote a paper highlighting the problem. I agree with you. Because of COVID-19, unfortunately, human safety, well-being has taken the, rightly so, as a paramount importance. So saving the individual's life is very important. Right now, most companies that manufacture PPEs that use plastics or polymers, they do not have time yet to look for alternative materials that are probably more sustainable. Because of the urgency around the world, most companies ramped up their own existing infrastructure manufacturing capabilities to generate PPEs necessary for the hospitals as well as the individuals. So, but these are designed to be single use. There are problems associated with sterilization. Most national standards are not developed for post-sterilized products. For example, you have a face mask and it's perfectly in good condition, but you used it. After you sterilize it, there is no standard yet that gives you the permission to use it. Because of that, the reason is the insurance companies have not caught on how they would actually insure the manufacturing companies of the PPE. That's one other problem. So we investigated this problem seriously. What we believe is post-pandemic, the world will begin to apply the impact of the improperly generated waste on the ecosystem and future calamities that would affect the survival of the humanity. So if you start beginning to think how the same PPEs with the similar performance, functional performance, if we can improve the circularity, sustainability, I think you are moving in the right direction and preparing yourself for the future opportunities in the right way. So right now, I think any transition is very difficult because emergency is much more about saving the lives, and the single-use plastics have been approved to use it. Any change to that one right now requires much more studies and a proper approval process. And I think that's where more efforts are needed. I'm very sure in the coming years that would take place.
Thanks, Professor Ramakrishna. There are many questions, but because of the limited time, we will forward you all those questions and you can respond to the participants. Professor Ramakrishna, we once again thank you for your very deep insight on the aspects of circularity and sustainability, which is going to also change the way future science and technology is going to emerge for a sustainable world. So thank you once again to you and all the our colleagues who have joined this very informative webinar. And next week, we will have Professor Kim from South Korea, who will be talking about the technical feasibility and the challenges in upcycling of waste polymers. And we all look forward for the next week on Saturday, another exciting talk, which is the last talk of the lecture series on material sustainability. So thank you once again, all, and Professor Ramakrishna. Thanks.
Well, I also like to echo thanks to Professor Gupta, and he is doing a tremendous work in terms of APA sustainability form. And I invite all the audience to keep an eye on what we do as an APA Sustainability Forum. Also, given the special circumstances of COVID-19, I like to wish you all stay healthy and remain mentally resilient. Thank you so much.
Thanks. Yeah.
Okay.